Okay, this is my center tapped transformer, single phase power. Maybe I'm looking at this backwards. I'm trying to figure out if this is out of phase with each other, 180 degrees or not. If I was to measure from ground to that, I'm going to get this. And if I measured from ground to this in the same orientation, I would get the flip side reverse of it. Would I say that's 180 degrees out of phase? Maybe it is. I don't even know anymore. I know that if I had some 120 volt loads right here and they were balanced, there would be no current on the neutral. So maybe this explains that. Maybe they cancel each other. Maybe that is right, because if I measured from here to here, I'm going to get that. And if I measure the same orientation from here to here, they're going to be in phase. It's just going to be one on top of the other, right? But if I use this as the reference both times and go from here to here and from here to here, then it's going to be flipped upside down. And if I measure from leg to leg, I'll have twice the amplitude in the same amount of time. And then if I flipped my leads over, it's going to look like it was 180 degrees out of phase, because the polarity, everything's going to look different. So if I was to measure this leg to that leg and this leg to that leg at the same time, it might kind of give me the same thing. Maybe it's just a matter of reference. And then that brings me to three phase. If you've got three phases coming in from the street and the power company gives you three transformers on the poles, A, B, and C. A to ground, B to ground, C to ground. They're 120 volts. The peak is 170, but they're 120 RMS. Measuring each one to ground. They're out of time by 120 degrees. So what happens if I measure from A to B? From A to B. So if A is right here in time, B is right there in time, then what about A to B? It would have to be somewhere in between, wouldn't it? It would have to be somewhere in between there. It would be 208 volts because of the 1.73, but where in time is it? And from A to C, that would have to be somewhere even further in time, but maybe not as far in time as from B to C. So where would those be in time in relationship to each individual leg? Or would they be in the same time? I'm really confused on that. At what time would you measure A to B and B to C? And then this is another setup that we have. I see this a lot. The power company is only going to give us two phases. And the first phase looks like this. The secondary, the center tap right there is going to be grounded, just like we had before. But the second phase is going to be one of these. And so I've got 120 to ground, 120 to ground, and then 208 to ground. And you have to make sure what breaker you're hooking up to your TV set. But I see this a lot, and three-phase equipment runs on it. I've got 240 volts between this leg and that leg. I got 240 from leg to leg, anywhere you go. This is the same phase. So I call them A1, A2, but some people would call them A, B, C, just like normal. I don't know which is correct, but I just know that this is 120 degrees out of time with that. Are these 180 degrees out of time, or are these in time with each other? So if I measured A1 to A2, I get that, and it's 240 volts RMS. What if I measure A1 to C? It's going to be 120 degrees out of phase? Well, what if I measure B to C? Since A and B, are they in phase with each other, or is that out of phase with each other? So what happens if I measure from B to C? Is it on that same one? Or is this going to be 180 degrees out of phase and just sync up the opposite of that one? Or what happens So these are 120 degrees out of phase, and this is 240 degrees out of phase, or is it 180 degrees out of phase? I'm really confused about this one here. But you can hook up three-phase equipment to it, and it works just fine. I don't understand how, but it works.